guys. I've changed my location for filming to make it a little bit easier on my kids. And it looks like we're going to be in this for the long haul. So hopefully the videos are a little bit helpful. Again, all the notes are posted on D2L as well as the filled in version. So if you learn better that way, then you can forego the video. If you want a little extra explanation, then the video is going to be for you. Oh, one kid's coming in already. Morgan, you coming in?
Yes.
Come in.
I don't care about my nippers.
Okay, you can put Ben's slippers on. All right, so if we move on to 3.5, the main idea with 3.5 is going to be something called measures of central tendency. So basically what we're looking at here is when you have a set of data with a whole bunch of different data points, what is the best number that can describe the whole set of data? And there's a couple different methods by which you can find the measures of central tendency, most of which you learned in elementary school. So things like the mean, the median, and the mode. And really, that's the gist of what we're going to be doing today is mean, median, and mode. We'll get a little more in-depth than what your definition was in grade 5, but basically going to be the same thing. So if you look, you have a note sort of like this. I'm going to post these online as well with my solutions in them. And Morgan, don't please. And the first question kind of looks like this. They list an NHL hockey team. Morgan, stop please. They list an NHL hockey team and they list the salaries of all the players. So the salaries range anywhere from $300,000 a season up to $4 million a season. Okay, and then on this side, they list the number of players that make each of those salaries. So if you kind of look here, whenever I use a double bar like this, I'm adding something up. So that's something that we've seen before. Okay, say hi.
Hi.
Okay, you want to work on another sticker page? What? Okay. Can you go work on a sticker page or something?
Yeah.
Somebody can work? Okay, so if we add them all up, we have 2, 3, 5, 13, 19, 20, 21, 22, 23, 24 players altogether that are on salary here. Okay, I can't fill up your water bottle right now. I'm working.
I need you to open it.
There, you can go fill it up. Okay, so there's 24 players, and they range from $300,000 a year up to $4 million a year. A couple things to note. Obviously, the majority of the players, the single salary that you look at the most is $750,000 a year. That's what we would consider the mode, the one that is most frequent. Okay, so 8 players make $750,000 a year. Very few players are making the high salaries. Look, only one player making $1.5 million, one player making $3 million, one player making $4 million. But there's also very few players making the low salaries, $300,000, $500,000. So when you look at this as a scale and you're trying to figure out, well, what kind of is, I don't want to use the word average because the word average is mostly talking about mean. But what is a salary that's sort of consistent among the players, or sort of, what salary would describe what the majority of the players are making? Okay, so in this situation it says Steve is a player on the team. His agent is renegotiating his contract. So they have all this information in front of them. And the manager of the team says, well, I want to pay Steve $750,000. He's like, most of the players make $750,000. Half the players, in fact, if there's 24 players, and I count here, so 2 plus 3 is 5. 5 plus 8 is 13. Okay, half of 24 is 12. So the 12th player in line, if I line these all up in order, is making $750,000. So in fact, what we call the median, or the middle, is also $750,000. Okay, that's the middle value. If I listed these all in a row, that would be the middle value. So the manager says, I want to pay him $750,000. I think that's fair. Half the players are making, the middle value is $750,000. He's about a middle guy. That's what we want to plan. Well, the agent says, no, I think he should earn $1 million. He says the average is $1 million. If I took all of these salaries and added them all up, 300,000 plus 300,000 plus 500,000 plus 500,000 plus 500,000, I would get $1 million. Okay, so what is fair? So this happens to be $1 million. what is a fair salary? And that's sort of a topic people go on. What is a better measure of central tendency? Do you think the average is what we should look at? Should he make the average salary if he's an average player? Should he make the middle salary if he's an average player? Should he make the salary that the majority of the players are making, the mode salary? And that's sort of what you discuss. Even in education, we've talked about this for a long time. Your mark is an average of all your marks that you've gotten on tests, assignments, and whatnot. We deal with average in education. For a while, they said, why don't we do mode? Why don't we use your most frequent mark? If you get one high one, it's not going to count. If you get one low one, it's not going to count. We want to take your most consistent mark. But overall, through that trial, education went back to, let's have an average. We think everything should be, should count that you've done. Sometimes not weighted exactly the same, and we're going to look at what a weighted average is, and that's actually what we're doing for your marks. But these are all measures of what we call central tendency. They're going towards the middle, the center of the data. Okay? So we start with that, and then from there we're going to move on to kind of official formulas and official definitions. Okay. So, by the way, I am out here in my backyard. This is a little cabin I built for the kids, but now it's turned into my little home office. So I like it better out here. Makes me happy. Okay, in terms of formulas, what we're going to use. In terms of a mean, and if you look on the sheet, there's two different things we use to represent mean. Sometimes we represent it with this kind of script M. It's called a mu. Okay, it's a Greek letter like many things in math. Or we represent it with an X with a line over top of it. And this we refer to as X bar. Okay, X bar is an X with a bar over top of it. Both of those are going to represent the mean or the average. One of them is for a population. Okay, so this one we use for population. So that's when you have all of the people involved that are going to be in the, or all the data involved. And then X bar is going to be used for a sample. So we've already talked about those definitions. Sample is a smaller percentage of an overall population. But both of them actually have the exact same formula. So in terms of finding it, you're basically going to say that the mean is the sum, okay, of all the X values divided by the total number of values. X bar looks a little bit different only because we consider this a small case n. Okay, small case n is the number of values in a sample, large capital N is the number of values in a population. So the one symbol you might not understand is this symbol right here. Okay, it oftentimes looks like that. This is a capital sigma. And what it's standing for is the sum of. And remember that sum is addition. Okay, so what that's saying, this looks way more complicated than it is. Okay, mean is simply add up sum of all your X values, add up all your values, divide by the total number of values. Okay, so if we looked at that hockey example, you would add up all the salaries that we had and divide by 24 because there were 24 players on the team. Okay, so it looks scarier than it is. Again, you're simply adding up all the values, dividing by the total number. Okay, make sense? Good. It's all written on your sheet, so that should not be a problem. Now, in terms of median and mode, we kind of talked about those already. Median is the middle value. Now, if it's an odd number of values, there is a distinct middle value. So say you have 15 values. The 8th one would be right in the middle. There'll be 7 on the left of that, 7 on the right of that. The 8th is the exact middle. If you have 16 values, now there's no exact middle. You have to take the 2 middle values and find the average of that. So again, to find the average, you would just add up the 2 middle values and divide by 2. So be aware, if there's an even number of data points, you're going to have a median that's going to be an average. Okay, and then the last one, mode, is the most frequent, the one that appears most often. Okay. Now, if you get to the example that we have next, which is about two classes, class A and B, you'll notice online that I have simply dealt with class A. It's just sort of repetitive for me to do both of them. So it gives you a bunch of marks. So basically a class's worth of marks. There's 17 values, and they want you to find the mean, median, and mode. Okay, so I'm not going to do it on here. You can clearly look at the way I've outlined it in very good detail on the note, and you should be able to tell. But basically, to find a class average, if you know everyone's mark in a class, you simply add them all up and divide by the number. So in this case, there was someone had 71%, 82, 55, 76. Add all those up, divide by 17, and we got an average mark of 71.4. And that's exactly what we're doing when we come up with our class averages. We simply add everyone's mark, divide by the number of people in the class, and you get the average. The median, and this is sort of an important fact, in order to find a median, you must list the data in numerical order from least to greatest. So in this chart, they're all scattered. It might be an alphabetical chart, who knows? All the numbers are scattered. So you need to take all 17 of those numbers and list them from lowest to highest. Because there's 17, there's a distinct middle. It's the 9th term. You'll have 8 on the left, 8 on the right. The 9th term is the middle. Happens to be 71 in this case. So you get a median of 71. Mode, you just look for what mark appears the most frequently. And 71 happens to appear 3 times. So your mode is 71. So we had an average of 71.4, a median of 71, a mode of 71. We would consider this an amazing set of data because all 3 measures of central tendency are almost the same. Okay, so that means that it doesn't matter which one you use, all of them are equally valuable, basically. Okay, there is a question on here that says, what is the effect of any outliers on the mean or the median? So an outlier is a data point that doesn't look like any of the other ones. So if you imagine a general class, most people's marks are kind of somewhere between 60 and 90. There will be, there's the odd kid that has a 97 or a 98, and then there's the odd kid that has 15%, 20%, and those are considered outliers. Now, the 98 kid is helping the average, and he's not that far. But if you have someone with a mark of 15% or 20%, that's pulling your average down. It has a great effect on your average, and then it can start swaying the data. People are thinking, oh, no one's doing well in that class. No, a lot of people are doing well. One person's doing bad, and they're pulling the whole average down. If we looked at the median, it would just be the lowest data point. The median would still be the middle value. The outlier has very little effect on it. So sometimes if there's outliers, you would be better to use a median value. Or sometimes even we adjust the data and remove the outlier because it's really swaying our data in the wrong direction. Okay, so just be aware, outliers will affect your measures in some way. Okay, the next example is one that you were supposed to do on a graphing calculator. I can't assume any of you have graphing calculators. I don't even have a graphing calculator, so we're just going to skip that. And then we're going to look at 2 different formulas for what are called weighted mean. That's going to be one of them. Okay, weighted mean, and the other one is called a, I don't know what I want to call it. Grouped mean, I guess I'm going to call it. Okay, so a weighted mean is very similar to a frequency mean as well. So there are going to be 2 different formulas here. So basically what's happening with a weighted mean, so we call it X bar W. And it's going to be the sum of all the weights multiplied by the X values. Now when I show this, there's going to be a little I here. This is kind of an index. So if you have weight 1 and your X1 value, weight 2 and your X2 value, weight 3 and your X3 value, all divided by an N value. Okay. Well, actually, this N is going to be more specific in this sum of all the weights. Okay. So when you do a weighted mean, it seems like maybe it's a little bit complicated when it's not. Let's save this for the next one. So the example they give is basically like this. you're in a job interview, and there's a couple things we're looking at. What's your education? What's your experience? What are your interpersonal skills? What are your communication skills? And references. Okay, now depending on the job, they're not saying that all of this is equally as important. If they said all of this was equally important, and you don't have, say, very much experience, should that go against you? So that's basically saying anyone in their 20s is not going to be have as good a chance at the job because they don't have any job experience. So a lot of times when you're going through a job interview, they've weighted things based on their importance for that specific job. So basically here, if this is you, this is what you scored out of 5 in each of these sections. So they said your education was great. Okay, maybe you have a university degree, they're pretty happy with that. Your job experience, poor. Maybe you're 25 years old and you haven't had a chance to have a good job. Who knows? Your interpersonal skills were awesome. Your communication skills were awesome. And your references were great too. Maybe you had some part-time jobs that you got some references from. Maybe you had some teachers that you got references from. So these are the scores they gave you. These are what we would consider your X values. So we call them XI values. And what it means is, well, this is going to be your X1. This is going to be your X2. This is going to be your X3, your X4, and your X5. Okay? Now the next column is going to be the weight that they're giving them. Okay, so your weight is how important it is for that particular job. So in this instance, they're saying education is going to be weighted a 2. It's not super important to them, and they're doing all their weightings from 1 to 3. So they want you to be educated, but it's not the most important. Job experience also weighted a 2. What they are most concerned with in this particular job is your interpersonal skills and your communication skills. So they say, you know what, I'm going to weight those a 3. And then they're saying references, not that important to them. They're weighting it a 1. And this is often the case. If you've put someone down as your reference and you've contacted them and said, can you be a reference for me? They're more than likely to say something good about you, whether it's true or not. So people feel like they need to back you up. So they'll often say something nice. Okay, so when we want to sub this idea into this equation, you're saying, here are my weightings. Okay, these are your WIs. And they go in order as well. So if your X value for your X1 was a 4, this will be your weight 1. This will be your weight 2. This will be your weight 3. This will be your weight 4. And this will be your weight 5. So in order to sub it into the equation, it's not overly difficult. It looks scary, but it's not. To find this average, this weighted average, you do the sum of all the weights multiplied by their X value. So you would do your first weight, 2, multiplied by its X value, 4. Okay. And then you will add that to the next. You have a weight of 2 with an X value of 2. Add that to a weight of 3, an X value of 5. Add that to a weight of 3, X value of 5. Add that to a weight of 1, X value of 4. And then you divide it by the sum of all your weights. So in this case, if I want to look at the sum of my weights, I have 2 plus 2, which is 4, plus 3 is 7, plus 10 is 11. Okay, so it's a simple calculation. You would go about doing it, and when you get the final answer, you get 4.18. So 4.18 would be a great score, because remember, your score was something between 1 and 5. So if this is what they were doing, if they were interviewing a panel of a bunch of people, and they gave you scores all the way through, and then they averaged your score, and then they would look at maybe the top 5 people, all the people that got an average score of above 4 maybe, and that's how they would select the person for the job. Okay, so this is called a weighted mean. It's just saying it's not as easy as just adding them all up and dividing. It's only one extra step. But again, don't be scared of this sigma symbol. It's saying the sum of your weights multiplied by your X value. So you just do the multiplication, W times X, add it to W times X, add it to W times X, add it to W times X. Okay, so the very last thing we kind of want to talk about is what I called a grouped mean. And a grouped mean only has one extra step, and I don't really need to go through the whole example with you. You can see it worked out. But a grouped mean is when you have data that covers a range. So in this case, they're talking about number of hours that you watch TV, and the number of children in each category. So these numbers are going to be pre-isolation numbers, I think. Now kids are watching too much TV. So they're saying, okay, if you watch 0 to 1 hours, just one kid in their study. If you watched 1 to 2 hours, it would be 4 kids. 2 to 3 is going to be 7 kids. 3 to 4 is 3 kids. 4 to 5 is 2 kids. And 5 to 6 is 1 kid. So the issue with this is if you are trying to find an average for this, what number do you use when you're talking about the number of hours? So this kind of acts like an X value here. And this is talking about sort of a frequency. Okay, so we would call these are XIs, these are FIs. Okay, how many kids are looking at each of those values? Now, we can't sub in the range 0 to 1. We can't sub in the range 1 to 2. So what you do in this case is you take the midpoint of these. So the actual values we're going to call our X's are going to be 0.5, 1.5, 2.5, 3.5, 4.5, 5.5. Okay, so if you ever have a range of data, you have to pick the midpoint, the one that's directly in the middle of the range. Okay, now in terms of how that goes, if you have a frequency, you could write these all in a row. Some people don't like doing a frequency type mean, and they'll say, I have 1.5. I have 4 1.5. So they sort of write them all out. 0.5, 1.5, 1.5, 1.5, 1.5. They look at all their data and they go from there. That's a little bit monotonous in what it is, but some people prefer just adding them all up instead of using the formula. So some things to be aware of. We need to know what this adds up to. 12, 15, 16, 17, 18 people. And you can use this formula. So this is basically the formula for if you have a frequency, same as a weight, but you take the frequency multiplied by the XI value and divide by the sum of the frequencies.
Mommy.
Yes.
That adds up to 18.
That does add up to 18. Okay, so you take the sum of the frequencies times the XIs, divide by the sum of the frequencies. So in this case, frequency is here, XI is now here. So I'm taking the 1 multiplied by 0.5, adding that to the 4 multiplied by 1.5. And then you keep going, and this all gets divided by 18. Okay, so no different, but a little different look at the formula. I would say this is a very easy concept that becomes muddled by the fact that the formulas look a little bit ugly. You really have to wrap your mind around this sigma symbol because you're going to see it appear more than once in this course. Okay, so it just stands for the sum of. Add everything up, no matter what it says. So this is the sum of your frequencies multiplied by your X values. Why is the I there? Because this is X1. This is frequency 1. This is X2. This is frequency 2. X3, frequency 3. The I is just representing an index. Which number? How many I's are we going to have? Well, in this case, we're going to have 6. If there was more data, we'd have more indices. Okay? It does list the homework on the page. So take a look at that, and I'll post that online, and we'll get to it. Morgan, you want to turn it off? You want to say hi? No? Okay. All right.
I have makeup on.